Alright, so let's continue with the analysis of, the analysis we're performing to find extreme values and optimizers with the goal of applying this to optimization problems. Okay, so let's look at an example. Find the smallest and largest value of f of x equals x cubed minus 9x squared plus 24x minus 10 on over I, the interval I, which is 1, 5. Let's look at the solution. So if we go back to the last comment, important remark that we made, so whenever we're maximizing, we need to set up aside the values of f at the endpoints and look for critical points and see what gives us the largest and mean possible values. So this is a function, and as he said, the whole point here is not to test at every single point between 1 and 5. So this remark here gives us all the candidates that we need to consider when maximizing, when finding the smallest and largest value of f of x. So what are the candidates? What are the endpoints? The endpoints are 1 and endpoints 1 and 5. So what is f at 1? 1 cubed minus 9 plus 24 minus 10. 9 times 1 squared if you want. Okay, so 5 is 6. Correct, so 25 minus 19, that's 6. What is f of 5? 5 cubed minus 9 times 5 squared plus 24 times 5 minus 10. $125 minus 9 times 25, 24 times 5 minus 10. Well, in fact, I should have factored this out to get something simple, but it doesn't matter. 5. So 45. $120, 24 times 5, well, I mean, you can correct me if I'm wrong. I mean, these are the values that I obtained for f of 5 and f of 1, 6 and 10. Okay, so let me see now. So the candidates for the extrema are the endpoints 1 and 5, and the critical points. Now, so we need to look now at critical points. And so let's note that f being polynomial this means it is differentiable everywhere. So there are no critical points that correspond to points where the derivative doesn't exist. The only critical points that we're going to find are points where f prime is equal to 0. So the only critical points are points for which the derivative vanishes, so points for which f prime of x is equal to 0. Okay, so what is the derivative of f of x? So f prime of x is 3x squared minus 18x plus 24. This is the same, we have a common factor of 3, so 3x squared minus 6x plus 8. So added up, we get 6. Multiply, we get 8. So it means we can factor this out as 3 times x minus 2 times x minus 4. Okay. And so what are the only critical points? And the points for which f prime vanishes. So critical points in this case are points f prime is, so let's erase this from now, f prime of x, points x is equal to 0, which in this case this happens for x at x equals, so two values of x, so when x is equal to 2 and x is equal to 4. So the candidates for extreme values are the endpoints which you already recorded and the two critical points. As we said, f being a polynomial, there can only be critical points of the second kind. That means critical points where for which the derivative vanishes, and and no other critical points. And this only happens in this case when x is equal to 2 and when x is equal to 4. So let's see what is the value of f of 2 then. This is the other one of the candidates that we have. 2 cubed. 9 times 4 is 24 times 2 minus 10. 8 minus 36 plus 48 minus 10. Okay, so we have 46 and 2, so this should be equal to 10, if I'm correct. Okay. Now what happens at 4? F at 4 should be 4 cubed minus 9 times 4 squared, which is 16 plus 24 times 4 minus 10 so 64 minus 90. Well, actually, yeah, this is just 3 squared times 4 squared, so that's 3. Yeah, 30 squared. Of course, that's 12 squared, so 144. 16. 96 minus 10. And that is equal to 6. C64 plus 96 is 100. And 60 minus 144. 16 minus 10 is 6. Okay, so I obtained the values of f at all the candidates that we have, so let's look at all of them. So the endpoints. F of 1 is 6, f of 5 is 10, f of 2 is 10, and f of 4 is 6. Okay, so that means that then the smallest among all these values is 6, right? And the largest among all these values is 10. So the so it's 10 inside that interval. Again, this is because f, again, let's go back to what happens at the endpoints. F of 1 was equal to 6. F at 5 was equal to 10. F at 2 was equal to 10. And f at 4 was equal to 6 again. So, and not only that, so the absolute min is and the absolute max are both achieved at the endpoints and also in the interior. Okay, so 1 and 5 are endpoints, and 2 and 4 are interior points. So it's attained at the endpoints, which is one of the things that could happen, and it's also attained at points for which the derivative vanishes, so critical points. Okay, so that's the first problem, first application of this. So we'll see more involved examples in the next few videos.